Sorry, guys. Yeah, like any good, software running your own business, there it is. Good. And we can all see this, right?
Yep, we're in editor mode. So
yeah, we'll get there.
Okay.
My whole network literally went down about 15 minutes ago, so I've been in a pan.
Fun.
Yeah, so any good presentation, we're like super ready to go. There you go. There's a whole presentation. Okay. So what I was invited to talk about was some of my own experiences trying to integrate HDF5 into Dream 3D. So what is Dream 3D? It's primarily it's funded by Air Force Research Labs primarily. We've been in continuous development since 2009, and what the idea was to create a nice unified, well, it's everybody's dream, right? A unified cross-platform framework to allow different codes to work together. So the issue at the time, this is back in 2009, that AFRL was trying to solve, as probably many of the larger labs that are on here today are trying to solve, is that someone comes in, they write code. It only works with their particular file set, or maybe very particular inputs and outputs, and it doesn't really talk to anybody's codes. And then they leave. And then no one can run those codes, no one updates them, that whole idea. So we were approached, or I was approached back in 2009 to try to help kind of start the whole idea at a small part of AFRL to design this kind of unified framework that would allow researchers to just have their concentrate on their algorithms and not worry about how it's going to talk to all the other algorithms that are currently being developed then and now. Dream 3D itself has a very strong focus on material science and engineering. We have applied it to other domains. It is primarily a GUI application. We do base it on Qt5. There is an underlying extensible framework under there, like any good software project should have. All the usuals are hosted on GitHub. All the links are at the bottom. And the whole idea, like I said, was to both foster that collaboration within AFRL and in between AFRL and their outside research groups, whether that be in academia or industry. And then one of the larger problems that they were facing at the time, again, this is it's the same thing over and over, but how do I get my data, just like Andrew was talking about, how do I get my data from one person to the other and not lose any of that valuable metadata that goes with it? People, as engineers, we've all done it. We've put all the very, very important metadata in the name of the file. This was an attempt to try to get people not to do that anymore. Those are the three main links to either take a look at Dream 3D or pull it off at GitHub. And then we do put a nightly dashboard. We have nightly continuous integration builds, and we'll get into that in a little bit. So this is just, if you're morbidly curious, this is kind of the user interface that we came up with. This isn't a Dream 3D talk, so I'm not going to go into it. But basically, each one of these is like filters. You start at the top, and Dream 3D will run them one at a time from top to bottom. And so what this allows is, you can see over here, we have 363 different filters. And so if you want to just write a filter to do some sort of, essentially some sort of data analysis, you can just concentrate on that. You don't have to concentrate on, oh, how am I going to get the data in? How am I going to get the data out? So this has allowed AFRL to accelerate some of that research. So you can, when you bring in the postdoc, they don't have to concentrate on writing IO all the time. So way back in about 2006, when we were on another project, we were looking at a way to, again, bring all this together, all the various binary files. We, did the normal, took a look around, looked at your options. Are you doing just standard images with a sidecar file, binary XML, plain binary files with another sidecar file? Like, we were trying to get away from that whole multiple file deal. We want one file that would, one file to rule them all for the Lord of the Ring guys out there. And HDF5 basically checked most of the boxes that we needed. The one box it didn't particularly check at the time, and we have to roll back, this is about 2006, there just wasn't a lot of HDF5 infrastructure built up. MATLAB, IDL, Python wasn't a thing. And so it's not like it was now where you could just, which is great, we can grab it from almost any language. So we had to kind of come up with a plan to make access to HDF5, either educate the programmers at AFRL how to program with HDF5, or we ended up coming up with a super lightweight kind of set of wrapper APIs for C++ around it at the top. And again, this was back in 2006, before all the nice things that we have now are there. So in the end, we sold it to AFRL as, you know, we're going to lower the developer frustration, lower the developer time, and we're going to create a more consistent file, you know, that we can move that among the various research groups. So the particular history with HDF5 and Dream3D, excuse me. So Dream3D was started in, late 2009. We started really messing about in 2008. Again, we kind of have to play the way back time machine. And some of the issues that we came up with, or we were facing, while HDF5 was cross-platform, there was a different build system on every single platform, or the three main ones, three main desktop. And when I say the main, I mean Linux, Mac OS, and Windows. There were some issues with the H5 Lite building and DLLs, and so, you know, but you work through that. It still has all the plus stuff that we want to use. I'm also a very large CMake advocate, even from that time, actually from the early 2000s, and I wanted to put a better build system, so I kind of experimented a bit with wrapping the entire HDF5 with a CMake build system. I kind of didn't have the time, but Dr. John, I'm going to butcher last name, Biddiscombe, who I think was somewhere over in Europe at the time, kind of contacted me and said, hey, he'd like to give it a shot. So we collaborated for about a month back and forth, and we were able to put that CMake, that's the CMake configuration system within HDF5. Then we had a lot of great input from the HDF5 group, Elena in particular. And so we handed that code off to them, and they maintain it. And I'm hoping they still embrace it to this day. It sure makes our life a lot easier using HDF5 and a lot of our other projects. It's just easier to configure it and compile it. And then, you know, then a good story, we moved, we tend to stay put on our versions of HDF5 to make things stable, but late in 2018, we did move to the 1.10 release. So that's kind of some of the history between Dream3D and HDF5. I like to think it's been a good history. It's been a fun ride. And I like to see, you know, all the development that's going on. And so ever since I saw HDF5 as an engineer, I'm like, yeah, like this is exactly what we need in science. This ability to move the files back and forth easily, self-describing and all that. So one of the pain points in my particular area of material science and engineering is an instrument called EBSD. That stands for electron backscatter diffraction. And the one sentence, if you're not familiar with it, you're basically using an electron beam to reveal the internal structure of materials. There's a couple of major OEMs to it. They're EDAX, Oxford Instruments, and Bruker Systems. And as is typical in the industry, they all have their own internal proprietary binary formats. They don't want to tell you, you know, how to read those. And instead they're like, hey, here's an ASCII data file. And as I'm sure we've all done, and we've had some talks today, reading multi-gigabyte ASCII data files isn't kind of what I want to do. It's not fast. So the Dream3D, part of the Dream3D project, we actually kind of generated an archive spec for these EBSD files. We we took into account EDAX, Oxford, and Bruker. They all have slightly different, it's all kind of the same information, but one OEM may name things slightly differently than the others. So we said, let's pack it all in an HDF5. It clearly makes the most sense. It's after it's in there, it's fast reads. We even wrote a paper about it. There's the link at the bottom. And so we just kind of went on our merry way for a while with that. We didn't really talk to the OEMs about it much. And then, so this is, the gratuitous on the left, this is kind of what the text files start looking like. And then we're going to take a whole bunch of them and shove them in an HDF5 file on the right. So along about 2013, things kind of started getting interesting within the EBSD community, and you had extremely high-end users, places like Navy Research Labs, Air Force Research Labs, and a few others that really wanted the raw data out of those machines. So we sat down. The first one we sat down with was EDAX, and we just approached them. Very friendly people, and we had a very honest conversation with them that we really need access to those files, to the raw data inside of it, and we think you should put it in HDF5, and here's all the benefits. And we had a several-hour conversation with them. I got an email a few weeks later, said, hey, can you send me some sample code on how to, in C++, on how to write to an HDF5 file. That was in late 2013, and by 2014, the first company had actually added support into their own data analysis to export that data, all of the data, out as an HDF5 file. And of course, when you've got competition, that kind of, when the competition sees what you're doing and how you're starting to win contracts, then that kind of starts the ball rolling. So in 2016, Bruker also sent me an email and said, hey, we like this H5 EBSD idea. Do you have any feedback for us? Here's what we did. And so they also now support HDF5. And then lately now, in 2019, Oxford Instruments also now will put out a standard, put out an HDF5 file. They actually just grabbed the H5 EBSD paper that we put out and just followed it as a specification for their first try at it. So it actually works really well with Dream3D. Bruker and EDAX deviated a little bit, but I'll take it. I'll take the wins where I can get them. It's been mostly over the last few years as we talked to those EBSD users about it, just as an outsider. They've all been very, I guess, thankful and excited that they can now get their data in a binary file format that's quick to load. They can hit it from any language. They don't have to spend time writing a parser in MATLAB or writing a parser in IDL or Python or any of the others. So that was it was a long journey, 6-7 years, but in the end, I think it's worked out very well, at least for that area of the science. When I just want to shift gears a little bit, when I was approached to do this presentation, the HDF group asked for some feedback on just general feedback over the years. So I just kind of wanted to address some issues that went on in the last few years. And it's a trend that with the particular open source libraries that we deal with, it seems to be a trend. And it's where they essentially tie up or put their they say they're open, but they put their source and their binaries all behind some sort of wall. And I'll put the walls in quotes because it doesn't really matter if it's a paid wall, a subscription wall, a free account wall. It's a wall. And what happens is, yes, you can sign up for it with username and password, but the problem is what's in the bottom part of this slide. Dream3D has a continuous integration build. We pull HDF5 from a repository every night and build it to make sure it builds, Dream3D builds, our SDKs build. And when it went behind a wall, it caused a lot of issues to the point that we kind of considered moving away from HDF5, which was a tough pill for me to swallow because I have been and will be a very strong advocate for the use of HDF5 in science and engineering. after a what probably could be described as a passionate discussion, but a very good one, on the HDF forum, I learned a lot about how the HDF group works, what their funding situations were, things that I just wasn't aware of. So after moving to that, after having that nice open discussion, things happened. I'm sure I had no part of that, but we are, I mean, very happily that all of the hiding it behind the things was corrected. Their repositories are now out on GitHub. You can do bugs and features and code reviews, which we've already started to take advantage of, go through the standard pull release. We're working with one of the HDF group engineers on HSDS to update it to one of our own one of our own use cases, and they've been extremely helpful in that regard, giving us code reviews and feedback. We can now easily get to all the HDF5 downloads, and again, in the time when we couldn't easily get to those downloads, I felt bad, but I had to put them on our own internal server so we could get them from there, so that our own continuous integration would work. So now we've wiped all that away. We pull straight from the HDF group. Again, like any business trying to get by in this day and age with an open source software, they need to make the case for continued support from their funding agencies. And I'm sure looking at the number of downloads helps out in that situation. It certainly helps out in our situation and for Blue Court software itself. So, not to sound like an HDF group rah-rah, I'm not a part of HDF group, just so we're clear. I have my own company, but I am a very strong advocate. And after, finding out over the summer, a better idea of the not the inner workings of HDF group, but at least kind of some of the issues that they face. If you want to contribute and help to HDF5, here's the various ways that you can certainly do it. One of the big things is if you're using HDF5 and you're stumbling a little bit with it, consider getting some paid support. It will help them. It will help you. It will help your project. If you've got a proposal coming up or a current project and you're dealing with HDF5, and again, take a long look or talk to your funding agency and see if you can squeeze out some help for the HDF5 group. I'm not saying but we should try to give back to the HDF group where we can and help them keep HDF5 going. So, and again, we get some comments within Dream 3D. Hey, I want to help contribute, but I don't know how to code. That's fine. I don't know how to write technical documentation that well. So we can help each other. So again, adding to the HDF5 ecosystem, whether you add code, unit tests, report bugs, help with documentation. If you've got a real, if you're using HDF5 on an operating system that they don't particularly cover in their normal build bots, and you can contribute a nightly build bot, great. Approach the HDF group about helping to get something like that set up. So all those things can help. So major takeaways that I kind of want to leave the presentation with are, at the end of the day, HDF5 has saved us a lot of developer time. I don't have to write specialized parsers. Everything is self-described, right? It's all the things that HDF5 is known for and that we like about it. People ask me what I really like, or how would I describe HDF5, what do I like, what I don't like. And I've summed it up over the years as the best thing about HDF5 is you can put anything in there you want. The worst thing about HDF5 is you can put anything in there you want. So you just kind of have to balance that. Again, I think Andrew had the previous presentation, if you're here for it. If not, you can grab it afterwards. it's these ideas of having a domain specific organization within the HDF5 file that goes a very long way to spreading a standardization for your particular domain of data. There is, over the years, there's been a large passionate community, and that's great. It keeps HDF5 healthy. I have firsthand seen how using HDF5 can foster that collaboration between research groups when you take that friction away of how do I get my data, or how do I read it, or hey, we wrote it this way, but you know, now you've got to write code and to read it. And if you're in the situation that you can be a strong advocate for HDF5 when writing proposals, please do that. HDF5 is not free to develop. HDF group could go into that more if they want to, although it is free to use. So, you know, remember that developers need to be paid for writing HDF5, and it is a spectacular piece of software. If you got a new project coming up, I know we do, and I know we've been talking to the HDF group about adding support where we need it in that project. And just a call out to everybody, the HDF group, I mean this very sincerely, are some of the best developers I've had the pleasure of interacting with. They're absolutely reactive, and they will help you at the drop of a dime. And with that, that's all I have today.
Thank you, Mike.
Yeah, thanks, Mike. That's awesome.
It's been a long road, guys and girls, ladies, but we're here, and I love it.
I want to comment on your comment about my help with CMake. I was running around and asking who can help Mike, who can help. We need to work, we need to make it happen. So I'm mostly cheerleader for this group. So my contribution is very exaggerated, but it was great to see, because CMake solved a lot of our problems. And now we're still gaining expertise, but it's much, much better. So thank you for your help. We really appreciated it at that time. Mm-hmm.
It was one of my, personally, it was one of my first large code contributions to an open source project. So it was a great introduction to it. Everyone was very helpful. The HDF group was enthusiastic about getting that kind of code contributed.
And the shift to GitHub is going to make things so much easier and better. I really think that's a huge win.
Yeah, and we've already put in our first PR for the HSDS. We have a use case for that, and John Reedy,
yeah.
Thank you, has been extremely helpful in doing some video conferences with us to review our code just like it should be done, and giving us great feedback on it. So yeah, I can't wait for GitHub to really get rolling for you guys.
Mm-hmm. We too, but we understand that it will be pretty bumpy road at the beginning, and we really take seriously contributions. And example, maybe I mentioned that in my talk, it's UTF-8 contributions that we really couldn't accept because they were not done right. But we are committed working with community to get things right and get it into the code. So thank you.
But now I agree with you, Elena, but now with GitHub, right, you can set up a branch, people can contribute it, we can work on that thing collaboratively across many people, get it into shape, and then it can be merged. And there's so much more opportunity when it's on GitHub.
Let's hope that this is the case. So let's see.
We moved internally about 2 years ago when I, just for context, Blue Court Software is, it's myself and 3 full-time engineers. So we're very small. And I didn't get to 3 full-times till about 3 years ago. And so, you know, when you're by yourself, you're just pushing and pulling code left and right. You're like, you don't really care. And you're like, whatever. Oh, I killed the build bots. I don't care. Fix it real quick, push another one up. And then internally, we just kind of kiboshed that and went, nope, it's a formal PR process 99% of the time now. And it has really helped is really helped myself in particular. My young engineers are staying up with all the C++ 17 and 20. And then I write maybe non-optimal code. I put a PR in and they're like, hey, and they give me, there's a nice code review there. Like, you know, you need to address these things. And it's Okay. And like Quincy said, you have the branch, you can push up the branch. You don't have to worry about killing anything on the trunk, and disturbing any, things. So yeah, it's been instrumental.
Yeah, and we will, I announced to the forum that we moved, but we still, there are some loose ends, and there will be technical webinar for people who would like to contribute to learn about our development process, how we'll do PRs, how things will be reviewed, because we have, we're using actions, and the code is formatted at, you will not be able to submit not according to the code by default that will be responsible to review the code between where you are. So stay tuned. There will be technical webinar on how to contribute to HDF5.
That's great.
Great.
That'll be a good thing. Okay, so that, thank you so much, Mike. Lots of good technical information, as well as some really nice discussion around the community aspects here. I think that's been great. We've got a break for another 4 minutes, and then Elena will host the last 2 sessions in today's meetings.